Automatically generating morphological variations for deforming characters is a challenging research task. This work presents a novel approach for cross-parameterization of articulated and animated characters to create new hierarchical and spherical representations. Our approach is composed of three processes: segmentation, hierarchical spherical parameterization, and hierarchical feature alignment. We adopted a fuzzy decomposition method to partition characters into meaningful segments. The probabilities in fuzzy decomposition are computed based on skinning weights. As a result, the boundaries between adjacent segments are an abstracted representation of the character's deforming features. We conducted a child-to-parent decimation process to reduce the segments down to base shapes. We then projected the base shapes onto spheres and inserted the decimated vertices back. Boundaries as deforming features are aligned in the spherical domain with the novel parent-to-child method. A sphere's child boundary contains a representative vertex linking to the child sphere. During alignment, the arc distance between corresponding representative vertices and the arc distance of the child boundaries in the parent spheres are minimized. Our approach conveys the semantic matching of deforming feature correspondences and reduces the twisting artifacts significantly on new characters, which make it possible to achieve high-quality results of 3D morphing, texture transfer, character synthesis, and deformation transfer. We illustrate the process of child-to-parent parameterization using the Ripper dog. Starting at leaf segments, non-boundary vertices are decimated to a single vertex. As the representative vertex, it is duplicated to the corresponding child boundary in the parent sphere. So, the parent sphere continues this decimation process until it finishes the root sphere. As a result, we obtained a base shape for each segment. Each base shape is then projected onto a sphere. The root base shape is a solid tetrahedron, while non-root base shapes are pyramids and projected conformally into a cone shape with open bottom. The rest of the vertices are inserted back in the reverse order of decimation and projected on the sphere's surface. During this process, we minimize the parametric distortion. Please refer to the paper for details. Given two hierarchies of spheres, their skeletal structures are not necessary to be identical. The spheres that don't have a corresponding one in the other hierarchy are merged into their parents, and merging is manifest. A rotational transformation is computed to align each pair of corresponding spheres. It determines the best matching of feature points from the child boundaries in the parent spheres by minimizing an arc distance. Please refer to the equations defined in the paper for details. This transformation computation starts at the pair of root spheres and continues for child spheres until reaching the leaf spheres. After this, child boundaries of each pair of spheres are further aligned to exact positions. The positions of non-boundary vertices are interpolated with a radial basis function. A 3D morphing application is used to evaluate if aligned features in the parametric domain convey semantic matching between 3D shapes. Here are morphing results with characters that have significantly different articulations, motions, and morphing styles. Our approach enables the achievement of seamless texture transfer and blending effects. It conveys the semantic mapping of textural features during their transfer and blending between corresponding segments. We show a deformation transfer example generated by our approach, where the human walks in Troll's walking style. With our approach, body parts and rigging branches can be mixed automatically, create variations, and synthesize new characters. Thank you for watching.